Welcome to another Unit Circle Survival Guide. Today we're going to be reviewing reference angles and how they can be helpful for us in finding exact values. So as a reminder, a reference angle is simply the angle formed by the terminal side of an angle and the x-axis. So I like to think about it as the amount of rotation needed to get back to the x-axis. So let's take a look at some reference angles in both degrees and radians. Let's first start by looking at the unit circle on the left, the one labeled in degrees. So looking at 30 degrees, the terminal side of the 30-degree angle is here, the x-axis is here, and that's how the reference angle is formed, by the terminal side of an angle and the x-axis. Or just think of how much rotation you need to get back to the x-axis. So 30 degrees is the reference angle. And that's a neat thing about an angle in the first quadrant. The angle will be its own reference angle. So think about 45 degrees. Well, its reference angle will be 45. You're simply working your way back to the x-axis, which is to 0 degrees. Do note that you cannot have a reference angle of 90 or greater. 90 is a special angle. It's a quadrantal, and so it's kind of its own thing. It has its own way of finding the ordered pairs and evaluating exact values there. So let's take a look at all the other angles that have a 30-degree reference angle. So looking first at 150, you can see that the terminal side of 150, we just highlighted. Here's the x-axis. And so it would take 30 degrees to rotate back to the x-axis, or look at the difference between 150 and 180. All right, similarly, we have 210. So to get back to the x-axis, we go here. Okay, that would be another 30 degrees. And same thing at 330. To get to 360, it's 30 degrees of rotation. So that's to get to the x-axis. So all of these angles share a common reference angle of 30 degrees. So now let's look at the angles that'll have a 45 degree reference angle. So we start here in the first quadrant. Of course, that is going to be a 45 degree reference angle. But notice 135 has a reference angle of 45, as does 225 and 315. Notice the relationship on the circle. It all goes back to those special right triangles and how we found the ordered pairs for each of these angles. So all of those angles have a reference angle of 45 degrees. So label that here, 45 degrees. All right, so finally we have our 60-degree reference angles. So look here, 60 and 240 both have a 60-degree reference angle, getting back to that x-axis, as do 120 and 300. All of those have that 60-degree reference angle. Knowing about reference angles will really pay off when you are evaluating exact values, because you can know your first quadrant angles and coordinates and simply find the reference angle for an angle that's outside of the first quadrant. Use the reference angle and your knowledge of the first quadrant to find whatever value you're looking for. All right, so let's take a quick minute to look at the unit circle on the right, labeled in radians. You'll find your reference angles in the exact same way as we did before. So let's look at pi over 6. Here's the terminal side. Here's the x-axis. So our reference angle is just the angle formed by those two. And this time we just give it in radians as our unit. So we have pi over 6 radians of rotation needed to get back to the x-axis. And so you can see the same will be true for 7 pi over 6, 5 pi over 6, and 11 pi over 6. So on the unit circle, all the angles that are a pi over 6 have a reference angle of pi over 6. So I particularly like finding reference angles in radians, finding exact values in radians, because it's just so simple in terms of, well, it's got that pi over 6. That's your clue. That's your reference angle. So let's label that as pi over 6 as the reference angle. Now we can look at all the angles that have a pi over 4 reference angle. So starting with pi over 4, to get back to the x-axis, we have pi over 4 radians of rotation needed. Same thing for 5 pi over 4, 3 pi over 4, and 7 pi over 4. All of those have a reference angle of pi over 4. It's pi over 4. And finally, we can see all the angles that have a pi over 3 reference angle. They need pi over 3 radians of rotation to get back to the x-axis. So see here, and again, it all goes back to those special right triangles. Even though we typically talk about them in degrees, it holds true for the radians. So hopefully side by side, you can see the comparison here and see that it is essentially the same thing that we're finding. So all those angles have a reference angle of pi over 3. Hopefully this helps you understand reference angles a little bit better, and we will definitely make use of these in the context of finding exact values. I'll be posting some videos about that pretty soon. Thanks so much for watching.